Welcome to Math TV with Professor V. In this video, we're going to look at an example of how to solve problems involving normal lines to surfaces. So the problem states, where does the normal line to the paraboloid z equals x squared plus y squared at the point 1, 1, 2 intersect the paraboloid a second time? So we have this paraboloid, z equals x squared plus y squared. You should be familiar. That's opening up in the direction of the positive z-axis. And they've already told us the normal line intersects it at the point 1, 1, 2. Where else? Where else? So in order to solve this problem, we first need to find the equation of that normal line. Okay, so I need the direction vector for the normal line, which I can obtain by looking at the gradient of the surface. So here the surface is the paraboloid z equals x squared plus y squared. I'm going to call f of x, y, z x squared plus y squared minus z. That way I can compute the gradient, right? So just set all the terms on the same side. And then now I'm going to compute the gradient of capital F. The gradient will give me a vector normal to the surface, and then that vector will be the direction vector for my normal line at the point 1, 1, 2. So when we're finding the gradient, remember we take all of the partial derivatives for the respective components. So first component, I'm going to take partial derivative of x squared plus y squared minus z with respect to x. So derivative of x squared will be 2x. And then derivative of the other terms with respect to x is just 0. Next component, I'm taking the partial derivative with respect to y. So I'll have 2y and everything else is 0. And then last component is -1, partial derivative with respect to z. So my normal vector to the surface is equal to the gradient at that point 1, 1, 2. So now I'm going to substitute in 1, 1, and 2 for x, y, and z. So I end up with 2, 2, and -1. So we use this as our direction vector for our line. And then we already have a point 1, 1, 2 right here. That's basically our x naught, y naught, z naught that we could use to write let's do parametric equations for this normal line. Okay, so here we go. Normal line time. So x equals, do you need a recap? If you have your direction vector v with components a, b, c, you write the equation of the line as x equals at plus x naught, y equals bt plus y naught, and then z equals ct plus z naught. So putting that all together here, we'll have 2t plus 1, y equals 2t plus 1 again, and then z is -t plus 2. So here's our normal line. Now, the problem states that this normal line intersects the paraboloid a second time. Where does that happen? So now I'm going to come back and substitute in 2t plus 1 for x into the equation of my paraboloid, 2t plus 1 for y into the equation of the paraboloid, and -t plus 2 for z, right? I want to see where does the normal line intersect the paraboloid. I already know one place. Where else? So here we go. Back into paraboloid equation. I'm going to have -t plus 2, that's z, equals x squared plus y squared. Okay, now you just have a little FOIL party. So -t plus 2 equals, if I multiply this out, I have 4t squared plus 4t plus 1. And this is the exact same thing. So really I have two of them. Ooh, so nice. Okay, so -t plus 2 equals 8t squared plus 8t plus 2. And then I'm noticing these 2's cancel. Let's set everything to 0. So I have 0 equals 8t squared plus 9t. So to solve, I'll just factor out a t. And then we have 8t plus 9. And then now here we have t equals 0, or t equals negative 9 over 8. So remember the parametric equations for our normal line where x equals 2t plus 1, y equals 2t plus 1, and z equals negative t plus 2. Now t equals 0, that's no surprise to us. If I substitute in 0 for t, then I just get the 0.112 that I used to create the parametric equations of the normal line. So that's the original point that was given to us. But the second place where the normal line intersects the paraboloid occurs when t equals negative 9 over 8. So now I'm going to substitute negative 9 over 8 here for t so I can get my ordered triple. So 2 times negative 9 over 8, that's going to be negative 9 over 4 plus 1. Same thing for the y coordinate. And then z coordinate, it's going to be positive 9 over 8 plus 2. And then let me clean that up. So 1 is 4 over 4, so this is negative 5 over 4, negative 5 over 4. 2 is 16 over 8 plus 9. This is 25 over 8. So this is the second point where that particular normal line intersects the paraboloid. Okay. And we have solved the problem. I hope that was helpful. If you want more solutions to specific Calculus 3 problems that I go over in homework with my students, let me know. This was a hot one that we did on Monday, and I thought maybe the people on YouTube will enjoy. If you need a recap, maybe you forgot how to write parametric equations for a line, or maybe you just don't understand what the gradient is. I have full-length video lectures on Calculus 3, as well as Pre-Calc, Calc 1, Calc 2. So check out the playlist on my YouTube channel, subscribe, give this video a thumbs up. You can also check me out on Instagram and TikTok and Patreon, Mac TV with Professor V. Love you all. Be back soon.